So we are having a pattern recognition problem in which we are having a handwritten digits which are scanned using some of the scanning devices, and the objective is to predict that what is the digit which is being scanned. And so these are all handwritten digits, and so these are in the form of pixels, around 28 by 28 pixels, and the objective is to predict it. So we are supposed to use any of the SVM techniques to predict it, and so it can be either radial or linear or any other technique. Uh, so talking about the data is provided by MNIST, which is National Institute of Standards Technology, American. So two files are provided. The train and test, both the files are provided separately, and the data contained are around 60,000 observations and 784 variables, which corresponds to 28 by 28 pixels, and so 60,000 trained data set data set observation and around 10,000 test data set observations have been given. So the first step in the data cleansing was to give accurate column names, because the column names were not provided. So the first column was the digit value which is to be predicted between 0 to 9, and the rest of the all were corresponding values of the pixel. So corresponding 784 values. So total 785 observation variables were there in the data, out of which the first was the digit value. So we initially converted that into a factor variable because it is to be predicted. We have not gone for any EDA in depth, just the basic NA value removal, because the model creation took too much of a time, and that's why we directly went from the basic data cleansing to creating the model out of it. So for starting the model, we used two techniques, which is the linear and the RBF dot. So starting from the linear method, so that gave us around. So when we use the sigma value from 0.025 to 0.5, and the cost value from 0.1 to 2, the result that it gave was around 97%, 91% accuracy for the vanilla dot linear dataset, and the linear data on the test dataset. When we so and the data model using the RBF kernel, so that gave us a little more accuracy, which is around 97%. Comparing both of them, we went with the RBF dot model, and so on the same on the confusion matrix as well, we came to know that the RBF dot is a good method of creating a model for this problem. And again, for the cross validation hyperparameters, from testing it on the grid for sigma from 0.025 to 0.05, and the cost value from 0.1 to 2. So the optimal values that we got after some testing was 0.05 for the value of sigma, and 0.1 for the cost, which is also the best kind of solution from the outputs. And when we applied this on the final model, so final model was constructed, the kernel used was RBF dot, and the gamma and cost value were 0.05 and 1. So when we applied this on the test data set, which is around 10,000 observations, so we got the accuracy was 97%, R square was around 73%, sensitivity specificity were around 97% and 96% respectively. So this is the entire picture that we got using SVM techniques for predicting the handwritten digits. Sorry. Thank you.